Hello everyone, welcome to another CFD analysis session. Today we'll do airfoil analysis. So this is the same experiment we do in our fluid lab where we use airfoil with the wind tunnel. So we're gonna create the same experiment on Ansys discovery using the same airfoil, which is NACA 4415. So yeah, in order to do the airfoil experiment in discovery, the main reason is the simulation. So we have the same experiment in Fluent as well, but for better simulation purpose and understanding the concept very well with the visual simulation effect, we choose discovery. So there are a few advantage with discovery is the first one is it's easy to use and a very simple application in order to have the simulation and results. One of the main reason is because the discovery does the meshing and everything individual automatically, so you don't have to go through that part over here. So another reason is for design. We don't do design it on the Ansys spacecraft like the way you do in Fluent experiments. We can have our design ready and simply import that design to Discovery. So for as we know, we can design it to any 3D software, and we can import it as we have done before for fluent experiments and steady state heat thermal experiments. The IGS format supports on Ansys platform as well. Same we can use discovery, but for this particular experiment we will use STL format. So as we have already drawn our geometry in SolidWorks, we will just import that suitable format file of the airfoil to discovery. So for that, first we'll just go over here and select that discovery from drop down menu, and we'll simply drag it over here to create the simulation analysis. From geometry, we'll right click and import our geometry. So as I have done it before, so I can see that my files are here already showing me. If you are doing for the first time, you just simply click on browse and just go to the location where you saved your file. So from here I will select the airfoil 4415, and as you can see the right mark where it says geometry, that means my geometry has successfully imported on the discovery platform. So now I'm gonna right click again on geometry and I'm gonna select edit geometry in discovery. So we can see that our airfoil has successfully uploaded, and it's ready for our analysis purpose. So now, as I mentioned earlier, that we do this experiment in a wind tunnel. So you have to create a virtual wind tunnel over here. So for that we need an enclosure and the inlet and outlet direction of that enclosure, so that we can replicate that wind tunnel over here. So there are multiple ways to create your enclosure, especially in discovery. You can manually do it, and you can select the enclosure or whatever shape you want. But for our use, we will select the type of flow, and we want the internal flow. And the one good thing with it is when we select internal flow, it automatically create a enclosure for us over here. So we just need to select our inlet direction. So I will select our inlet direction, and you can see that enclosure is created. Now we'll click on the bottom part of the enclosure, and that define our enclosure main enclosure over here. So as you can see now, my object is sitting actually on the floor of the enclosure, at the bottom of the enclosure. So that's not where I want my enclosure to be. For better simulation purpose, I actually need to move my object over here towards the middle of the enclosure. So for that, I will simply go to the design and I select move, and I'll select my object, and I will simply drag my object toward the middle section of my enclosure. And as you can see, my enclosure is pretty large, and it's not exactly the identical enclosure that we have in our wind tunnel. So we're gonna resize our enclosure a little bit. So I'll select this edge and I'll reduce the length of the enclosure like this. Similarly, I will select the front as well and I will reduce the enclosure size. And in order to have a better viewing window, I will select this edge and I will drag this one just very near close to my object edge, so that my edge is exposed. So when I will do my simulation, I will have a better clear window view of my simulation part over here. So after defining my object position and my enclosure, I will simply go and select the material I want for my object. So from here I will change my material, and as you all know, for typical airfoil we can actually use aluminum alloy 6061 instead of stainless steel or structural steel. So we're gonna go and select that, and we will then select the type of fluid. So we'll come over here and we'll select air, and as you can see, whatever medium you select, actually you will get all this detail over here: the mass, molar mass, density, and viscosities as well. So after doing that, I will enable the gravity, and I will select the temperature. So for, if I consider a typical Boeing 737, and it's fly typically between 30,000 to 40,000 feet above. So in that region, the ideal temperature will vary between 45 to 57 degrees Celsius. So I will come and simply do it Celsius, and it will be negative 57 degrees Celsius. And for walls, everything is already defined. I don't need to define anything special over here. As I can see, if I move my mouse, it actually showing me that's my non-stable body object, which is my my model over here, and that's my ground and the extended walls. For flow, typical 737 flies somewhere between 500 miles per hour to 600 miles per hour. So we need to, as you can see, it's a meter per second. We need to convert that. So if I take the maximum 600 mile per hour and times it to with 0.44704 meter per second, I will get somewhere 268.224 meter per second. So let's do that. My bad, 268.224 meter per second at negative 57 degrees Celsius. Yeah, so that's pretty much it. We need to define everything for that particular experiment, and we'll just start our simulation part of it. Oh, before we do that, the explorer option over here, or the fidelity, it actually it is the level scale where we can define like for how long and or what type of simulation, I mean what not type of, or how long and how better simulation you want. So I always like to have it in this some sort of half or less than half, so that it doesn't apply excessive load on my graphics card. And now we're gonna just go and click on the solve button. As you can see, it started the simulation for us. We can actually define our viewing angle, and we can actually add particles in it. We can also do add the direction field. We can add the streamlines. We can add vectors. We can add contours. We can add isosurface. We can do actually a lot of things, and we can also change our viewing angle from whatever angle we want to view our simulation. So if you look over here on this corner, it's showing our max velocity is 365 meter per second, and we can actually analyze for different other different purpose as well, like a static pressure. We can see the results and simulation for static pressure. We can go for temperature. We can do a lot of various things, and special over here, if we come over here, and it gives us a window of the main results, like a max temperature, max velocity, or pressure drop. So these you can also add graphs if you want. So these are the thing we can do on Ansys. We can do the charts for different purpose. We can export this data to Excel sheet, which I recommend to note down your data and draw the chart on Excel sheet instead of using this chart. And this was a simple airfoil experiment simulation experiment on this Ansys discovery. So the next one we will do on Gulf War. So thank you everyone.